Hi, and welcome to this new session on the types of learning. As usual, let me kick this off with a couple of questions. First, do you remember how did you learn to read and write? Second, on the same line, do you remember how did you learn to play your favorite game? We would probably all agree that reading and writing consisted pretty much in spending a lot of time in memorizing the shape and the sounds of all those symbols. Becoming a superhero in our favorite game might have also required a lot of time and attempts, but the learning process would be more autonomous and complex if compared to the previous one. Associations between symbols and sound is basically all you need to learn how to read, while on the other side, knowing how the rules maps into the game is just the starting point of the challenge. You will have to figure out your own winning strategy. In real-life scenarios, humans, like all living creatures, have many different ways to learn how to do something. The same would apply in the machine world, and we can categorize different approaches in 4 groups. Group number 1, supervised learning. In this case, the learning process a machine can learn by associations. For example, let's assume we would like to teach a machine how to recognize pen versus non-pens. So in the training phase, what we would like to do is to teach the machine that this is a pen, this is another pen, this is not a pen, and this is not a pen neither. Can you imagine what could have happened if we labeled this as a pen at the beginning? So that's how important are the correct labels in the dataset. In summary, in this approach, the more couples of item and labels we have to teach the correct concept to the machine, the higher is going to be the chances that our machine is going to be well robust in answering and labeling correctly the unseen samples. The group number 2 is unsupervised learning. In this case, the learning process is based on similarities. In most of the cases that falls within these categories, all we have at the beginning is a bunch of data points without any labels. The task usually consists in grouping those data points in a meaningful way or generate new points based on the information we can retrieve from the points we already have available. Was this too technical? Okay. Let me give you an example. Think about a wedding day when all the invited people get to the restaurant. Usually, the tables are organized with some metric in mind, such as the table with their colleagues from work, the table with friends like in childhood friends, and the table with parents and relatives. Well, as you can easily understand, it doesn't matter if we have a wedding planner or a machine performing the split. All we have in both cases is a bunch of data instances, could be either points or people, for which we would like to generate groups in a meaningful way in order to move further. Third group is semi-supervised learning. As you can easily imagine, it's a kind of a combination where we have among the dataset labels for a few of the entries in the dataset, and some of them are missing. Performing an initial grouping on all those data could be extremely helpful to understand how to automatically assign the missing label, starting from the one we already have. Group number 4, reinforcement learning. Here the approach is pretty different from all the previous ones. The only common thing is that ultimately we want to teach a machine how to perform a task. But how? In reinforcement learning, we have 4 key components. 1. The list of action, meaning the list of action that the machine is allowed to take throughout the process. 2. The status, meaning something that can describe where the machine is in a given time. 3. Reward function, like a score counting. 4. A goal to achieve, like teaching a machine how to drive autonomously. In this context, the learning process consists in letting the machine experimenting with different actions. You can actually think as a random approach, just let the machine playing with the environment. The machine is going to start at a given state, and as soon as it takes an action that will move it towards the final goal, the reward will be released. By the end of the learning process, the machine will have automatically learned what actions are more effective to achieve a goal. By the way, I'm conscious this is just a very simple explanation of reinforcement learning, and if you'd like to find out more, I'm gonna leave you some links for you to check out. Now that we've learned what are the paradigms we can leverage to teach a task to a machine, let's see what are the techniques available to implement them.